Hey students, it's Tuesday, December 8th, and if you are struggling with today's lesson about multiplying binomials times binomials, or if you missed class, here's a catch-up video for some of this. Again, you're going to have to practice, pause each of these sessions, or each of these sections, try it yourself, and then rewatch it. We're looking right here at the do first. What we see is we want to match the products with each of these pieces. So if I look at this 3 times negative 9, I know that there's no variables there. So the product of these will be a number without a variable. 3 times negative 9 is negative 27, so I look through here and we match these up. All right, I'll find another one right down here. I have negative 5 times negative 6. That's 30. Negative times a negative. X times x is x squared. So grab that 30x squared. Go ahead and put that together. Now, try out each of these slides. And on the next slide, the answers are there, and you can go back and forth. All right, take a moment to do this. So hopefully you did the do first. You're able to check your understanding and go. Today, our goal, we're going to multiply a binomial by a binomial. And then we're going to throw in a little twist and see if we can even up the ante a little bit. So we're going to do an error check for exponents. We're going to look at the area model of monomials and binomials using an area model. And then we're going to do a team challenge or exit ticket. You're watching this, go ahead and you're going to work on this team challenge questions by yourself before the homework. So this error check, when we look at these, we're trying to figure out which one of these are incorrect, and we're going to cross it out and say what's correct. So pause and try that out. Well, when I'm adding bases, right, the exponent shouldn't change. So I have 2 and 2, and this becomes 3 for some reason. That doesn't make sense. We have 1x plus 2x, 1x squared plus 2x squared. That should give us a total of 3x squared. This one's correct. I have 3x to the third and 1x to the third for 4x to the third. And then finally, if I have x squared plus x squared, I have a total of 2 of those, thus 2x squared. All right, pause for a second and check these out. So hopefully you paused, but take a look. When we multiply our bases, we add the exponents. So here I have 1 times 2 is 2. X squared times x squared, adding 2 plus 2, we do get 4. That's correct. Here I have 3 times 3 is 3. And when I multiply the bases, I add the exponents. 3 plus 3 is, wait a second, what's 3 plus 3? It's 6. So this one is incorrect. And finally, x times x, we get x to the 2 plus 3 is 5. That one's correct. Multiply the bases, add the exponents. Pause this one and take a look. So this one's a little bit of a mixed one, right? We're adding these two bases, so do we change the exponents? No, so that looks correct. 3 plus 12 is 15. Good. Here I'm adding, so do we change the exponents? No. 12 plus 4 is 16. Wait a second, 12 plus 4 is 16, but why do I have x to the 6th power? When we add the bases, we don't change the exponents, right? And so this one's incorrect. What do you think it should be? Yeah, it should be 3. All right, and finally this last one, 4 times 4 is 16. X to the third times x to the third, x to the 6th. So that's when that exponent gets added together. Notice the difference between these two. All right. So here is our review from yesterday. We'll take a look at this first one up here because this one's a little bit different from yesterday. But if I have x times 2x plus y, we write the x on the edge of the area formula, 2x times y, and we multiply our sets of boxes. X times 2x is 2x squared. X times y is xy. So neither of these have the same variable. This is x squared, this is xy. So we write it as 2x squared plus xy. Try out the other 3 and then take a look at the next screen for your answers. Okay, really important, you try them first, check your answers. If you have questions, that's when you come 1 to class and 2 to office hours. Hopefully you were able to figure that out as you went through it with the monomial times a binomial. That last one was times a trinomial, but I know you got this. So here's today's goal, right? We're going to take a binomial, 2 elements in a number, times another binomial, which also has 2 elements. And you can see our example is 4x plus 5 times the quantity 3x plus 6. And so in this area model, I'm going to write the 4 and the 5 right over here on this side, 4x and 5. And then over here, we're going to write the 3x and the 6 on top. Very similar to what we just practiced. And so let's multiply each box. 4x times 3x. Sorry, I'm going to 4x times 3x. 4 times 3 is 12. X times x is x squared. Okay? And if that's getting a little sloppy, just listen. 4x times 6, so I have 4x times 6. Well, 4 times 6 is 24. X times, oh, there's no variable there, so it's just 24x. Notice one variable in the multiplication problem, x to the first power. Here I have 5 times 3x. 5 times 3 is 15. There's no variable here, there's x, so it's just, I have 5 times 3x, or 15x. And then finally 5 times 6, we get 30. So I would rewrite this as 12x to the second, 12x squared plus 15x plus 24x plus 30. And if you look in this next screen, it's already done for you right here. But there's one thing that we're missing. What else could we do right here? And you can go ahead and type that in, what else you think we should do. So pause it. Do you know? All right. Hopefully you really tried this. And so look at these two. They have the same variable to the same power, so we can combine like terms, right? We can combine the terms that are the same. And so we end up with 4x to the second power. We can combine 15 and 24, so that adds to 39x plus 30. Notice all the work we've been doing to get to this? All right, submit that. Let me know that you understand your thinking. And let's try it again. So this one's all on you. So take a moment, pause, and try it. All right, did you really try it? I hope so, because it's only going to help you get better. So we put our x and our 3x, or our x and our 3 from our first binomial. Then we're going to put our 2x and our 1 right here from our second binomial. We're going to multiply x times 2x is 2x squared. 3 times 2x is 6x. X times 1 is x, and 3 times 1 is 3. We're going to write that out, 2x squared plus x plus 6x plus 3. And we're looking, what can we combine? And we see we can combine these two numbers. So go ahead, type that in. Look at the next slide for your answer. All right? And if you have a question, reach out to me, ask it. So we have two more. 2x plus 1 times 2x plus 1. That answer's right here. And then 2x plus 5 times this trinomial, x plus y plus 2. Oh, I have to remember, I made a mistake right here. This answer is not 2x. This answer should be 4x plus 2x plus 2. So hopefully you're watching this, you get 4x squared. 4x squared plus 4x plus 1. Even I make mistakes. Well, I make a lot of them. So make sure you have that as your right answer. And here's some of your other classmates, right? Even Ernesto saw that I did it incorrectly. So, all right. So finish off these problems and then come on back. So how do you feel about those problems? Did it make sense, I hope? So what we've been practicing is called the distributive property, okay? Distributive property says that it has rules for how we organize and multiply a monomial times a binomial, or a binomial times a monomial, or any of these different types of things. So what we're going to do is we're going to just grab two of these problems from this last slide, and I want to show you how can we do this without using the area model. Remember, yesterday we used the area model to multiply 2x times 6x and 5, and we would do what's inside each box. Well, here, if I just know that 2x needs to multiply times each thing, we can say 2x times 6x, 2 times 6 is 12, x times x is x squared. And then we go ahead and multiply the next one times 5, 2x times 5, well, 2 times 5 is 10, so 2x times 5 is 10x. How'd that feel? Go ahead and try this one without using the area model. I know you didn't. Pause it. Pause it. All right, here we go. 6 times 4x. Well, 6 times 4 is 24. 6 times 4x would be 24x. Then 6 times 1, 6. So boom and boom. Hopefully you understood that. That's the goal of today's class. So when you finish that up, go ahead and come to this slide 24. I want you to write down the steps you need in order to multiply a binomial. Tell me that you understand this by finishing this off. Then, if you miss class, go ahead and shoot me an email and say, hey, finish class, would you check out my exit ticket? And then to prove that you understand this and to get the practice down, go ahead and go to Delta Math and go to your assignment, which is called distributive property. Once you make it to your distributive property, you can go ahead and show that you understand it by completing those. And let me just give you a quick overview of what those skills are. The first skill is going to be how do you distribute a constant into two binomials. Okay, so do this on your own paper and then type it in here. So 8 times -9 is negative 72x minus 8 times 3x squared is 24x squared. Remember, use that Shift 6 to use the caret to get up and do that. I'm going to submit that answer. Oh, looks like I did it correctly. So it will walk you through how to do each of these pieces as you see it to make sure you're understanding. Watch through this, all right? Now, if you don't understand, remember there's a help video here, okay? There's 2 more pieces. This next one is using increases just a little bit, and you have 3 of those. And then finally you have 4 of these, a binomial times a binomial. It says express it as a trinomial, and remember that means that you're supposed to have it in 3 terms. So x times x is x squared, x times -1 is -1x, 4 times x is 4x, and x times 4 times -1 is -4. Notice I have 4 parts of this. That is not a trinomial. I need to make sure I combine these middle 2 terms. -1 plus 4x is going to be a positive 3x. When I submit that answer, like I got it right, it can walk you through each of these pieces. And look, they're using the box method, the area method. So probably a good idea to use that area method as much as you can and keep growing. All right? So any questions, please reach out, watch the help video, grow as much as you can in this lesson. All right, have a good day.